This conference will now be recorded.
Good morning, friends. Welcome to goonlinetrainings.com. We were talking about business integrity. So, yesterday we had seen a lot of relationships, right? So, it is what is called data modeling. So, there are three types of relationships between tables. It could be one is to one, or one to many, or many to many. So, we have one to one. So, wherever you have one to one, and we can take any table's primary key and make them as a foreign key in the opposite table. That's what we had seen it. Clear? And in 1 to m, we can take only the parent table's primary key. It can become a foreign key in the child table. That's what we discussed. And in the many to many, we got to create one more table, that is what is called a bridge table, by creating two foreign keys in that, and some attributes which are getting much more data, not only one value. For example, salary and date of joining. So these attributes must be kept in the bridge table. So that's what we discussed yesterday. Now, this is my department table and this is my employee table, right? So one department can have many employees. It is completely many to one is to many relationship, right? So you have a table. What table I'm talking about? A department table. This is what is called employee table, right? So you cannot now you need to understand what is this table. I'm talking about department table. And this is what is called employee table. One department can have many employees. One employee has to work for only one department. So this is a situation in my company. In other company, one employee may work for many departments as well. If that is the case, it will become many to many relationship. So in this case, so this side we have one and one. So what is the maximum? One is the maximum, because one and one, when you compare it, take the maximum value means you will be able to get 1 year, right? And m and 1, what is the maximum value? M. So you should be able to take, it is called as 1 to m. If you reverse, it will become many to 1. If you reverse employee and department, it will become 1 to m. So already we told that, so we have a department ID, employee. So once you identify the entities, then you need to know what are the attributes. That means column names. So you will have lot of columns here. So lot of columns, but I wanted to take only few columns, right? So few columns I can have it. Now, which is the primary key in this? The primary key is so in this table, the primary key is this. In this table, the primary key is this. Clear? Now, how can we create a primary key and foreign key relationship? I told you clearly which is the parent table. Wherever you have one, so that table is called as a parent table. Wherever you have m, that entity is called as a child entity. So you have to identify what is the parent entity and what is a child entity. So this is what is called my parent entity, and this is what is called my child entity. Only for one to many you will have a parent and a child. One to one you will not be able to have it, and many to many also you will not get it. So what is the rule here? The rule is parent table primary key only can become foreign key in the child table. So this is what is the rule. Okay, so that is what I'm talking about today. Why not the other way around? So that is what we'll discuss today. So why only the parent table primary key can become a foreign key? Why can't we take this employee ID, the child table primary key? Why can't we have here as a foreign key. So that is what we're going to be discussing today. So in this case, we'll have, so this is the table structure I'm talking about. A department table, 1, 2, 3, accounts department, purchase marketing department. So this is the department name, employee ID, name and department ID. I am entering the data. Okay. This is one-to-many relationship. Now, so the foreign key is perfectly created. Now this is what is my table. This is the parent table and child table. If you see carefully, 1006F, the department ID 99. Do we have 99 department? When we create a primary key and foreign key relationship in SQL Server, whenever you enter any data, if you don't enter any data, nothing will happen. If you enter some data, yeah, if you enter some data, what RDBMS software, SQL Server, Oracle, MySQL, any software, what it does, it takes 99 from here. It is going to be taking this value and verifying, is it 99? Is it 99? Is it 99? No, it is not a 99. So entire row gets deleted. So this is what is called referential integrity. Remember this point. Clear? So whenever you enter the value in the foreign key, whenever you enter a value in the foreign key, SQL Server or Oracle or any other RDBMS softwares, what it does, it is going to be taking this value and verifying, is it 99? No. Is it 99? No. Is it 99? No. So when the this value does not exist here, so entire row gets deleted. You will get a message, foreign key violation error. What is the error you get? Foreign key violation error. So this kind of a existence check is called as a referential integrity. Integrity means correctness. So by referring the parent table, so SQL Server is going to be ensuring that. So whatever be the value that has been provided by the end user is existing in this table or not. Clear? SQL Server performs existence check when we create relationship with the help of a primary key and foreign key. This existence check is called as a referential integrity. You will get a foreign key violation error. Remember this point. When you get foreign key violation error, that means whatever be the value that you're giving here, so that is not existing in the primary key table. So that is what you need to remember forever. So this is a common error that you're going to be getting everywhere. Clear? So now entire row gets deleted. Entire row gets deleted. Now, I want you to understand one more point here. So let me take Excel. I'm creating department table. Now department ID, department name is here. Okay. So department ID 10, sales department at 20, accounts department and 30, let us say technical department. Okay. Now what we were doing, we are creating an employee table. Now employee ID, employee name, and we were creating department ID is a foreign key here, right? So this is the parent table and this is the foreign key that has been created. But what I wanted to do, I don't want to create like this. I wanted to have like this. This is completely wrong. But if I keep this primary key here, what will happen? Let us check. Because you need to also know what is the issue, right? If I create an employee ID as a foreign key here, so as a foreign key here, what will happen? Clear? Now I am not putting like this. I am making a employee ID as a foreign key here. Okay. So this is the primary key. This is the primary key. And this is the foreign key I'm doing in the reverse order. For example, now we have one, John is working. And we have two, say Alex is working. We have three, say we have Salman is working, like that. Okay. So we have Raj is working. We have a couple of people going to work. Now I wanted to have in this department who's the employee ID. For example, John is working. So on which department? This department. Okay. So now I need to enter employee ID. Here one. So what is the meaning of this? So 10 sales, one. One means John is working here. Alex is also working in the same department. So you need to enter, put a comma and put a two here. So this is what is completely wrong, right? So according to RDBMS, you should have only one value. This is one value. This is one value. You cannot have one comma, two comma like this, and it is difficult because tomorrow Salman is also working in this company. You will say three, and tomorrow 10,000 people are going to work. Will you write 10,000 entries here? If you have 1 million people, will you write 1 million people numbers here? It will be irritating job. So instead of creating like this, so the better way is that you create like this department ID. So John is working department number 10. So this is what is the clear thing. So Alex is also working, even Salman is also working, and Raj is working for department number three. So this will give you better design than this kind of a design. Clear? So whether your design is right or wrong, you will come to know when you insert the data and see your structures. When you insert the data, you will come to know you're ending with this kind of an issues. Now you will decide, no, this is the wrong design. So this is not the way. Clear? So when you insert the data, that only then only you'll come to know whether your design is right or wrong. When you use the tables, because tables are there to store the data. Now better to insert the data. Then you'll come to know the design is right or wrong. You're constructing in a house. While construction, do you know whether good or bad? You don't know. When you use it, when you go into that and keep on using that, you will come to know that, so this is the bad idea. I should have constructed this there. I would have removed the pipe there. I would have have the toilet there. I would have created a bigger room there. So when you use it, you will get more and more ideas, more and more designing changes. Clear? So design always you will not be able to understand at the time of development, during the development. Okay, once you develop and try to insert the data, so you will come to know a lot of designing issues. Not only here, anything, even you purchase a bike, when you use it, you'll come to know whether it's good or bad. So when you see the bike, you don't know whether it is good or bad. So designing is always, okay, designing is always, when you use it, you will come to know the problems of the design. Clear? The problems of the design. So whether we need to create a foreign key here, you cannot decide now. But when you have the data, then definitely you should be able to see this is the proper design. Clear? So parent table, this is the parent table. Parent table primary key only can become a foreign key in the opposite table, but not vice versa. This is a completely wrong design. Clear? Is completely wrong design. So that's what you need to understand. Clear? So we have to say this is what you need to take it and make this as a foreign key. Am I clear? So what is the referential integrity also we discussed, and why we cannot have the employee ID as a foreign key here. Am I clear? Clear? If your design good or bad, you will come to know when you use the design. So have some dummy data so that you will understand if your design is good or bad very clearly. Am I clear? Now, what is the referential integrity? I told you clearly, whenever you create a primary key and a foreign key relationship, and people may ask you some questions. When we create what is a foreign key, right? What is FK? So it is used to establish, it is used to establish relationship between tables in RDBMS systems or softwares or tools. Clear? So remember this point. So because of relationships only, database management system is called as a relational database management system. Clear? And This is the one thing. It is used to establish relationship between tables in RDBMS tools. Clear? So what kind of relationships we can have? We can have one to one or one to many or many to many. Clear? If you have a one to one, what will happen? Any primary key can become any primary key can become foreign key. So there is no issue. Clear? So in this case, we have two tables and we have two primary keys. And I told you we can have only one foreign key, but everybody recommends you create two foreign keys here. Now here, what will happen? Parent table primary key can become a foreign key in the child table. So this is the point here. Clear? And here we have two tables. We have two tables and two primary keys, but foreign key is only one, that to parent to child, P to C. So parent to child. The next one is called many to many. What will happen here? So in this, one more table, bridge table will get created. Clear? So bridge table will be needed. Okay, without that, you cannot achieve this. Clear? So I clearly told you, not two tables here, one more table gets created, and a two primary keys and two foreign keys as it is will be there. So these are the learning points. When you create a primary key and foreign key and have the proper designing, so this is what is called data modeling. Clear? So people would ask you, do you know data modeling? Do you know how to create a primary key and foreign key? Do you know how to identify one is to one, one to many to many? To understand one is to one, you should know the business. You should know the domain knowledge. As a technical person, I cannot decide this table and that table will have one to one. I told you, right? So I told you one parent will have many children. So if you know about India or America, that is true. If you know about China, that is false. So even though you're technically very sound, whether it is one is to one, one is to m, you cannot decide. You should ask the business. Clear? So whether it is one is to one, many to many, or one to m, a technical person cannot decide that. A domain person, people who are into business, probably the people who are in the business, they will be able to tell you. The client can tell you these tables are in one is to one relationship. Clear? So these tables are in one is to many relationship. So this a technical person cannot identify. If somebody says this is many to many, how does that guy know? That guy is already got the information from the client. Otherwise, that guy is not a Aristotle or a Socrates, or is not a intelligent person. No, nobody is intelligent. You need to ask the business persons only. Clear? If somebody is saying one is to one, that means what? He got the information from somebody else. He cannot identify on his own or on her own. Remember this point. Okay. Technically, even though you have 50 years of experience, you will not be able to identify how the tables have been linked, whether it is one is to one, one to many to many. That information you supposed to get from the business. Business means customer. You should ask them how these two tables are linked, how these two tables are behaving. You should ask them. Then only a technical person can understand this. So once you understand this, creating these things are called data modeling. So create a primary key, take a foreign key there. So this kind of a things a technical person can do that. So what technical person cannot do? You cannot decide whether this table is in one is to one, one is to a many to many. That you cannot decide by blindly seeing the table structures. No, you need to know the business, understand the business, then you can decide this. Am I clear? So data modeling is very, very important. It is used to establish relationship between tables. So when you create a foreign key, then what happens? It also checks for existence. It also checks for the uh, it also performs existence check. Okay, Check. So this is also very, very important. Whenever you give any kind of a data in the child table, foreign key relationship is going to be ensuring this number is available. Whatever be the number that has been provided in this, it has to be there. Clear? So this is my foreign key. So no employee can have a non-existent department ID. Am I clear? Now, department ID is the foreign key. Can we have duplicate values in the foreign key? Somebody asked the question yesterday, right? So let me write those points. Can I have duplicate values in foreign key? The answer is yes. Can we have a duplicate values in foreign key? The answer is yes. Without a duplicate value, you cannot have like this because A is working for accounts department, B is working for department number 3, and C is working for department number 2 and 2, and there are a lot of duplicates data. Non-existing values cannot be there. And one more question asked by Hemant yesterday, right? So can I have null values in a foreign key? The answer is yes. So without a null value, we will not be able to have the foreign keys. Foreign keys will have lot of null values. Clear? So the next question, how many how many foreign keys per table? Do we have only one or multiple? The answer is many. So I think we can have many foreign keys. That's what we need to understand. How many foreign keys per table? We can have many foreign keys per table. Clear? So how many primary keys per table? Already we discussed these points. Only one. Clear? And how many foreign primary keys per table? Only one. It can be composite primary key. So how many unique keys per table? Many. Clear? So you can have many unique keys per table. Am I clear? So that is what is very, very important. So what is the question? How about primary key? Does it have null value? Now you tell me. You have attended a lot of sessions. Primary keys. Okay. So what is the primary key? Primary key will not allow null value. Write this point in your notebook and underline it. Right. Watch the videos and please, take this because we discussed all these points, right? Again, so primary key, no nulls. Can we have nulls, null in primary key? The answer is no, right? So can we have null in unique key? The answer is yes. How many null values? Only one null. You cannot say more than one. Only one null value per column. Okay. In a table, you can have a lot of unique keys, but it will allow only one null value per column. Clear? So these are the points. I want you to understand one more thing here. Let me take out this. I have a table. I have a table like this. Okay. So let me take a table, employee ID primary key, employee name, employee manager ID. So every employee will have a manager, right? So let us talk about Microsoft company. So Bill Gates is the employee. The first employee in the company is Bill Gates. Now I have a primary key, employee ID, and this is what is called a foreign key. I'm going to be creating. Foreign key is referring its own table's primary key. This is what is the something new that you need to understand. Why? Manager is also an employee. Clear? Foreign key need not refer a some other table primary key. So this is one more table. It can refer like this. But I am talking about my foreign key is referring my own table's primary key. So this kind of a tables are called as self-referential tables. Clear? So because the manager is also one more employee, manager is also one more employee. So this is referring its own table's primary key. Then this table is called as a self-referential table. Remember this point. Self-referential. Okay. Self-referential table means a foreign key is referring its own table's primary key. Bill Gates doesn't have any boss because Bill Gates is the boss for the company. It is a foreign key. If you think that foreign key should not allow null, then you will ask Bill Gates, sir, tell me your boss. Bill Gates says, no, I don't have any boss. I am the boss for the company. Foreign key has to allow null. Otherwise, you will go mad. Clear? But this is a primary key. You cannot have null here. So the next, say, John is one more partner. John is also one of the partner. So he doesn't have any boss. These two are the partners for the Microsoft. They don't have any boss. They are the boss for the company. Now tomorrow, Alex joins. When Alex joins, Alex is reporting to Bill Gates. So Bill Gates is one. That means what? When you give one, foreign key will take one and will verify. So is it one? Yes. Is it one arrays? It is. It has to be there. Otherwise, it will not allow. You cannot give eight here. If you give eight, what will happen? Is it eight? No. Is it eight? No. Is it eight? No. Is it eight? No. It is not there. The entire row gets deleted. Remember this. You will get a foreign key violation error. The entire row gets deleted automatically by the SQL Server or Oracle. This is how the behavior of the software. Clear? You cannot enter a not existing value. You may say he's reporting to one. Now, so we have Satya Nadella. So this is the Microsoft CEO today. Clear? So he joins today in the company. He's reporting to one. Alex is now reporting to this guy. So Alex may be now reporting to four. Four is what? Satya Nadella. He's the current CEO of Microsoft. Clear? So you can have five. Bhaskar is joining the company there. So Bhaskar is reporting to Alex. Alex says three. Clear? So I can have a table with the primary key and foreign key, and my foreign key is referring my own table's primary key. Then this table is called as a self-referential table, and I have a foreign key. Foreign key is, should have multiple null values. If you don't allow null values in the foreign key, now this kind of a situation, you cannot handle it. Clear? So technology is there to handle the business, right? So the technology has to handle the business. Otherwise, what will happen? Never business will support the technology. You have to invent a technology that has to that has to support the always the business. Business is not there to support your bloody technology. Remember this point forever. Clear? If you say, sir, according to my knowledge, I cannot have a null value, then the company will say, get lost from here. We don't need you. Learn the concept clearly and come back. Clear? So definitely foreign key should allow null values. Otherwise, this kind of a situation in RDBMS, you will not be able to, you know, model it. Clear? So what is a self-referential table? What is a self-referential table? That is also one more interview question. So you have to be, what is a self-referential table? The answer is A, foreign key is referring its own tables, its own tables primary key. Then the table is called as what? Self-referential table. Clear? What is a self-referential table means? A foreign key is referring its own table's primary key, or it can also refer its own table's unique key. Anything is fine. Clear? Its own tables, primary key or unique key, then the table is called as a self-referential table. Remember. And according to me, so this is one foreign key. Now I wanted to know this guy may be working for a department. Okay, department ID. So you have a department table somewhere here, right? So department table we have created. I deleted the department ID, department name, right? So this is one more table we have it. So department ID number 10, we have a technical department at 20, we have R&D department at 30, we have a development testing department like that. We have a lot of departments in our companies. So, so this is the primary key here, and this is one more foreign key here. This is one more foreign key. Bill Gates is working for R&D department 20, and John is working for, let us say technical department 10, and Alex is working again testing department number 30, and Satya Nadella is working for R&D department. So, or you can say he is working for business development. He is working for business development department. So department number called 40. And Bhaskar is working for testing department called 30. Clear? So I have one foreign key. This is referring here. And we have one more foreign key that is referring here. So these are the different things that you can have them. So this is one foreign key is referring here. This is one more foreign key. It is referring here. Okay, like that you can have one more foreign key, it may refer somewhere. You can have one more foreign key, it may refer somewhere. You may have one more foreign key, it may refer somewhere. Lot of tables it can refer. Clear? So one table can have many. One table can have what? Many foreign keys. But one table can have only one primary key. Primary key will not allow null values. Foreign keys will allow null values. Primary key is no duplicate, no null values. Clear? One table can have only one primary key, but many foreign keys you can have. Am I clear? So in which table you supposed to fill in the data first? Is it a primary key table or foreign key table? So always you have to fill in the data in the primary key tables, because if you don't have 10 here, so can we have 10 here? If you insert a 10, we don't have any data here, what will happen? So definitely it is going to be failing. Clear? For example, I don't have any data here. I don't have any data here. Can I insert 10 here? Without having data in the primary key table, you cannot give the numbers here. If you give the number, it is going to be verifying. Do we have 10 here? No, it will fail. So always remember which tables to be inserted with the data first. So definitely primary key tables need to be inserted with the data first. Then the foreign key tables can be inserted with the data. Clear? Otherwise, if for example, if I don't have data, this line is not there, but I'm trying to give 40 here. Will it work? No, it will not work. Referential integrity 40. Is it 40? No. Is it 40? No. Is it 40? No. It will fail. So you need to have this row first, then only you can give 40 here. Clear? So which tables need to be inserted with the data? Always primary key tables. Then at last foreign key tables. Am I clear? So these are the important interview questions that you should know clearly. Can we have duplicate values in a foreign key? Yes. Can I have null values in foreign key? Yes. How many in a foreign keys per table? You can have many foreign keys per table. And how many primary keys per table? Only one. How many unique keys per table? Many. Unique, can we have nulls in primary key? The answer is no. Can we have nulls in unique key? The answer is yes. How many? Only one null value per column. What is a self-referential table? Okay. A foreign key is referring its own table's primary key or unique key. Then the table is called as self-referential table. So these are Very, very important things. Now, I wanted to talk about cascading features. What if primary key or unique key column in parent table changes? What if a row in the parent table is deleted? Solution is cascaded update and delete features. Cascading features cannot be implemented on self-referential table. What I'm saying, it is like this. Tomorrow, I wanted to remove this row, marketing row. Can I delete? Yes, you can delete. There's no problem. But if you delete, what happened to this guy? This guy is working for department number 3, and you're saying, I would like to delete this record or row. This guy is also working for department number 3. Now you're saying, marketing department, I don't need it because these people are not working perfectly. I wanted to remove this department from my table. There is a feature called cascading update and cascading delete. Okay. So cascade delete. You're deleting something in the parent table. So by default, it will have on and off. Okay. So if you make it on, what will happen? If you delete something here, corresponding rows will be automatically deleted in the child table. So this is what is called cascade delete on. If you make a cascade delete off, what will happen? You can delete this record row, but no action is done in the employee table. So the employees are there, but department is not existing. It will allow. So now what you do, you transfer this guy to department number 1, you update this fellow to department number 2. Clear? Because you need the employees, but you don't need this department at all. You're updating these guys first, then you should be able to delete this row. Clear? So this is what is called cascade delete on. On means if you delete something in the parent table, corresponding rows will be automatically deleted from the child table. When you make cascade delete on, if you make it off, no action is taken in the child table. That is the meaning. The next one is called cascade update. Cascade update means what? It is also it is also same. I wanted to update 1 to double 1, 2 to double 2, 3 to double 3. If you make it on, all ones will become double ones, all twos will become double twos, and all threes will become double threes automatically. If you modify the primary key value here, automatically the new values will get reflected in the child table if you make it on. But if you make it off, even though you do a lot of changes in the parent table, no action is done in the child table. You will have inconsistency. It has become a double one, but still it is a one. It is a double two. It is still it will become it will be still t because you're switching off. It is double three. Still it is pointing to three. So sometimes when you have millions of data in the child table, when you have millions of data in the child table, you don't want to touch the old values, but whenever you insert the new data has to be inserted with double one, double two, double three, but you are not touching the old values. So there is a lot of inconsistency in the database. So that a SQL Server will allow. If you say cascading update off means you will have inconsistency in that values because you are saying one does not exist because it has become double one, double two, double three, something like this. Old values we cannot update because we have so much of a data that you cannot touch it and update. So millions of data, when you have it, you leave the old data, but new values, whenever you insert a double one, double two, double three. Clear? So this is what is called, cascading features. What is the foreign key? Parent and child tables will have foreign key in the child table, unique or primary key in a parent table, and enforce referential integrity. That's what I told you, right? So now cascading features also we have discussed. Cascading features cannot be implemented on self-referential table. Why? Because in the self-referential table, what happens? If you delete this record and this, because if you delete four will get deleted. If you get delete four and one will get deleted like that. So one is linked to one. If you delete something, one more record will get deleted. So maximum table will get deleted. So cascading, features cannot be on, cannot be on the self-referential tables. Always it is off in the self-referential tables. That is the interview question. So now we wanted to discuss check constraints. Okay, column level check constraints we have, table level check constraints we have, and multiple check constraints where check constraints can be implemented. For example, I have created an employee table. Employee ID is the primary key. Employee name, I don't have any condition. Gender, I wanted to restrict. Gender could be either male or female. Salary should be greater than zero. Okay, if the grade equals to A, salary is less than 5,000. If the grade equals to B, salary is greater than 5,000. Like that, this kind of a validation to be given at the table level. So all these things can be implemented with the help of check constraint. Simple expressions: salary greater than zero, grade can be either A or B, gender can be either male or female. So these are the things if you wanted to implement. We cannot use primary key, foreign key, all of them. You have to write the check constraint. Clear? So check constraint means it will allow only following operators. You can write lot of expression. Loops and programming cannot be implemented. You don't know what is a programming. You don't know what is the programming. So if and else loops, all of them cannot be implemented. A simple expressions you can write: salary greater than zero. Gender can be either male or female. Grade can be either A grade or B grade. Okay. It always works within the same table, cannot work across the tables. Use check constraints when the requirement is simple, else use triggers. Check constraints are faster than the performance. So, what is the meaning of this? So, check constraints are simple expressions like this, mathematical expressions like this, that you can implement as part of your databases and tables. So, whenever you insert the data, SQL Server will ensure that it is having the proper values. If you have some other wrong value, if you enter a negative number in the salary, it will say salary has to be positive number. So I did not have the expression, but salary greater than zero, like that. Clear? Chicken sense are very, very good and simple expressions, mathematical expressions you can write. But if you wanted to implement complex expressions, means you must leave or you must not use, check constraint. Triggers need to be implemented. So we'll discuss the triggers later. So, for example, you lost your laptop, you go to the police station and complain, right? But a country is attacking one more country. It is a complex situation. Police cannot handle. A army, navy, air force people can handle it. Defense people can handle it, right? Simple things can be resolved by police. Complex things, complex wars and everything are going to be handled by military, defense, army. Clear? A simple validations can be done by the check constraint. Complex validations can be done by the triggers, right? Check and sensor are fast in the performance. You can reach police very, very easily. You cannot reach army easily. Army has a lot of guns, lot of machines, so that they have to carry whenever they go for the war. So triggers are very heavy. Triggers are very, very heavy, so they can support for the validations. But always we need to use a check constraint. If not, you have to go in for a triggers. Clear? What is a trigger? When to implement trigger, we'll see later. But understand the check constraints first. Then we have two kind of a check constraint. One is called table level and column level. Expression involving only one column. Salary greater than zero. Gender can be either male or female. Grade can be either male or female. Only one column I'm using and writing an expression. Table level means expression can involve more than one column. So here, grade is one column, salary is one column. If the grade equals to A, salary is this much. If the grade equals to B, salary is this much. This is a table level. This is a column level. This is a column level. So salary greater than zero, column level, right? So you can have a column level check constraint and table level check constraint, and you can have multiple constraints per table. Clear? So whenever you insert the data, if you have these kind of expressions, SQL Server going to be verifying one by one, one by one, one by one. That's what you need to understand. Now, the last concept is identity property. Automatically generate employee ID for each new employee. Clear? So, set for integers and decimal columns, identity seed and increment or decrement, integers or negative integers, only one column per table, no nulls and no default values, unique values. It may have gaps when the data is deleted. So, what is the meaning of this? Let me tell you. I'm going to be creating a table called employee table. Okay. So, this is my table. I don't have any data. And let me take one more column called salary. Now, I wanted to have automatic number to be generated in this column. Employee ID, I don't want to insert manually. I will insert only the name here. I'll say John. Say salary is 1000. So when I insert this, automatically number has to come. Okay. So if you wanted to get automatic number, so on this column, you have to create what is called as identity column. So we have to create what is called as identity. So identity will have two things. One is called seed. The second one is called increment or decrement. Okay. So remember this. What we are going to be creating? We are going to be creating an identity column on this. So we are making employee ID is identity. So identity will have two things. One is called identity will have two properties to set. One is called seed and increment. Seed means a starting number. Seed means what? It is a starting number. So starting number is 1, increment is 1. If I give you these values and the starting number will be 1, then if I add one more row here, the next number would be 2, the next number would be 3, 4. Why? Because starting number is 1, increment is 1. If I give starting number is 1, increment by 5. So 1, you will get 5, you will get a 10, you will get a 15 like that. Okay. If I say starting number is 1000, increment is -1. That is also fine. You will get 1000, you will get 999, now 998 like that, 997. So like that, you are going to go to 0, -1, -2 as well. Clear? So you should be able to give what is the starting value, what is the increment. Only one identity column we can have per table. So only on the integer columns we can create the identity. Identity means what? Automatically the numbers are going to be inserted by SQL Server. You need not insert the data in it. So you will take care of these columns. This is automatically will get inserted. You cannot have, I wanted to have 4.5 and 0.5. You cannot have decimal values. This is what is not allowed. Clear? So this is a wrong entry. Decimals are not allowed. So positive number, negative number, any integers are allowed, but what is not allowed? Decimals are not allowed either as part of the seed or increment or decrement. So entire table you can have only one, identity column per table. So remember this point. Identity column means automatically the numbers are going to be generated in that column. You have to supply remaining column data. This column data will get generated by SQL Server itself. Clear? So this is what is called identity column. Clear, guys? So this completes business integrity. Clear? We've spoken about a lot of things, right? So what are the things we discussed? Lot many things we discussed, right? We discussed about null, default, primary key, unique key, foreign key, check constraints. Triggers will, will implement them later. And check constraints and triggers, both of them are there to validate the data. Clear? Simple expressions means we can go in for this. GUID is automatically generating hexadecimal number. Okay, it is not I need one, I need two, I need three. It will not give you like that. It will give you some hexadecimal number, unique number it will give you. Yeah. Check constraints, triggers, and identity. Clear? So these are the things we discussed. Triggers we did not implement it. We'll see them later. The above features are used to validate the data in the SQL Server, but identity is a human understandable number. It is a unique number, but I wanted to give starting number is this, ending number is this. You can have this kind of a things. But in a GUID, you cannot give you I need a starting number, ending number, and GUIDs are not human readable. Understand that. Nobody can understand the number because it is in the hexadecimal format and very, very big numbers, but they are unique and automatically it will get created. But there is no, starting. I would like to start from this, end from this. That kind of a things you cannot give. So here, automatic number can be given. So this is human readable numbers. For example, employee IDs, and I would like to have serial numbers. All of them can be implemented with the help of identity. So barcode numbers, any other numbers can be implemented with the GUID. Yeah. So these are the things we discussed. If you have any questions, we are welcome. From Monday, we don't have class tomorrow because being Christmas. So tomorrow, Friday, Saturday, Sunday, we don't have any classes. Monday, we'll be meeting same time. We are going to be starting with the lab. Clear? So people have to install the software and get ready. So Monday morning, that means Sunday night for you, right? So US people and Canada people, Sunday night for you. So Monday we are going to be having a lab. Clear? We're going to be discussing about the lab from Monday. Make sure that you have installed the software within these 3 days. So happy Christmas, guys. No class tomorrow. If you have anything, so please let me know, right? Any other questions if you have, please let me know. Can we ask for help dumping those days? Yeah, during those days you can help, no problem. Can ask. Tomorrow and after tomorrow you can ask any help, and Sunday, no. Yeah, guys. So happy weekend and happy Christmas, guys.